Alright, so in section 2.4 we learned how to multiply real numbers, whether they are positive or negative, and today we are going to use the distributive property. Now the distributive property is when we have a set of parentheses and we need to multiply in a number. Now the way we can show you how to do that is this is the property, and something that I find really helpful is to remember to arc the a into both terms inside your parentheses. Same thing goes when we have subtraction, AB minus AC, and it's the same arcing motion to get that a into both terms. Okay, so now we are going to distribute on each one of these. So same arcing motion, this is 4y plus 12. We can go the same thing the other way. Y times 7 plus y squared. You can rewrite that if you want as y squared plus 7y. I always like to do the greatest power on the left side. N squared minus 9n. 8n minus 16. Okay, same thing. Distributing a negative number this time. Negative 2x plus negative 14 is negative 2x minus 14. Now we're going to distribute negative 3y into both terms. This is going to be a positive 3y squared. This is going to turn into negative 15y. Negative 2x plus 11. And n plus 3. Okay, so now there's some different terms we need to learn. When we have an expression, like any of the ones we just were distributing, the terms are the parts of the expression. The coefficients is the number part of a term with a variable. The constant is the number part with no variable. So when it's just a number by itself. And like terms are terms with the same variables. Okay, so now we're going to identify the terms, like terms, coefficients, and constant terms. Terms, like terms, coefficients, and constants. The terms are each individual item in this expression. So 3x, negative 4, negative 6x, and negative 2. Your like terms, 3x and negative 6x. Then we have negative 4 and negative 2. Coefficients, those are the numbers in front of the variables, so it's 3 and negative 6. And your constants are negative 4 and negative 2. Terms in the next one, part B, negative y, 8, negative 6y, and negative 13. Your like terms, negative y and negative 6y, negative 8 and negative 13. Coefficients, negative 1, negative 6. Constants, 8 and negative 13. Okay, we are now going to simplify the expression. So we need to do the distributive property twice in this expression. Once for the first, once for the second. So 4n plus 36 minus 6 minus 3n. Now we need to combine our like terms. 4n and negative 3n are like terms. 4n minus 3n is n, and 36 minus 6 is 30. Okay, last problem. Your daily workout plan involves a total of 50 minutes of running and swimming. You burn 15 calories per minute when running and 9 calories per minute when swimming. Let R be the number of minutes that you run. Find the number of calories that you would burn in a 50-minute workout if you run for 20 minutes. Okay, so here we have some number of calories that we're trying to solve for. When you run, burn 15, and when you swim, burn 9. Now I had to multiply by 50 minus R because we know that we run for 20 minutes, but we don't know how many minutes we swim for. So we have to do 50 minus R. Okay, so we know that R is 20. This is the generic equation for any situation. And now we're going to plug in our specific example. 15 times 20 plus 9 times 30. 570. That's how many calories you burned. Okay, and that was the distributive property section 2.5.